Here we go. Good morning,
Okay.
good afternoon, and good evening. And thank you for joining to get another Neo4j Live episode. Today, we talk about no-code graph exploration with Semspect. And my guest today is Vincent Vialard, who is the CTO of Semspect at Derivo. Hi, Vincent.
Hi.
How are you doing?
I'm fine. Keeping it cool.
Yeah.
Keeping the blinds closed most of the day. And
yeah. That's definitely a good idea. There was just a little rain shower here, so I opened the windows a little bit to get some somewhat cool air inside. It didn't help a lot. I'm already sweating. If you need to know. Yeah, cool. Yeah, as it goes, I'll do a quick highlight of this one before we dive in the content. Nodes is coming up in October, so we just closed the call for paper in 2 weeks ago, and yeah, we were currently looking at the submissions and building out the agenda. But if you are eager to get your seat already registered for now, you can go ahead and register. So go to the website that I've put in chat, and you can register already for the 26th of October. We will be running a couple of workshops again ahead of Node, so they start in September, but you will get all the information about them as soon as they are available, together with the agenda, probably in a couple of weeks' time. But yeah, Nodes will be fun, will be very interesting, very engaging, and it will be 24 hours almost around the globe. So no matter where you're based, you can watch. So if you usually watch these videos on demand later on and think, oh, I wish I could be joining live, but you are on the other side of the globe, don't worry. At Nodes, we will be live wherever you're based because of the follow the sun approach. So it's gonna be cool, and I hope to see you all join for Nodes. Yeah. But today we talk about Semspect. We talk about no-code graph exploration with Semspect and what that means and what that entails, I guess, a little bit. So if you are, if you have any questions, if you're using visualization tools or graph exploration tools already, have some pointers, some insights, let us know in chat. If you have any questions for the presentation as it goes along, then also please let us know, and I'll have an eye out for any of your questions and your remarks, and so we can discuss them during the session. But yeah, before we go into the actual details, maybe Vincent, can you share a few words about who you are, what you do, and yeah, maybe we can discuss a little bit how you came in touch with graphs. What was your
okay. So my background is in automated reasoning. I worked in the academic context for 10 years, and I went freelance for 10 years, spinning business ideas with friends. None of them was fruitful, and I was contacted by an ex-member of the laboratory at the University Ulm, at the Artificial Intelligence Laboratory, and they had just a couple of years before they had founded Derivo, and it's a company that was dealing with knowledge representation problems and techniques, and we had a joint project. I was hired for a joint project with the University Ulm to work on the conception of an inference engine for ontology web language. And well, I stayed at the company after that, and we were contracted by a law enforcement entity to develop a knowledge graph and an exploration tool. And as it happened, one of the co-founders of Derivo had worked on different kind visualization concepts, and we used these concepts that he had developed at the university to write the first version of Semspect. And this was around 2015, 2017, we actually presented the prototype at the International Semantic Web Conference. So we already had something running there. The UI was there. The backend was kind of prototype mode. and in the following years, we were offering supporting companies developing knowledge graphs. And we used this Semspect prototype at any time for curating the data, for understanding what we had built. And so we were pretty much in the RDF world. Coming from automated reasoning, we had quite high expectations about the standards and the ontologies that were used in this RDF data. And in the industry, well, the data did not meet our standards. So we had to do lots of cleansing and correcting the ontologies somewhere underspecified, overspecified, and our backend was very, very strict. So we had trouble doing that. And when we thought about rewriting the backend, we said, well, there are these label property graph. We had already used Neo4j as an embedded store for some of our data. So we were aware of that. And we said, in this world of Neo4j, it's not like RDF where you have data and metadata and model and meta model that can be mixed together. You have your nodes, you have your edges or your relationships, and you have properties. And that's all. And so we say, okay, all the problems we have with this mix-up that we get in the RDF world, we will get rid of that if we move to the label property graph. But Semspect was expecting some kind of model, and there is no model in the Neo4j data. But it's this simple model, but the model about the data, the kind of classification of the data we had in the RDF world, we had this hierarchy of classes, these complex ontologies. And this was not available in Neo4j. And the relationship between the objects were also not specified which labels are connected. So the domain and the range of the properties of these connections were not available to us. So we said, okay, let's go for this. The data is clean. And let's try to reconstruct the model from the data. And this is what we did. So we actually scan the database at the beginning and see how are the labels and the properties and the relationship used. So we build this internal model that we can then use to explore the data. We, like I said, we already had used Neo4j, and we were really impressed with the efficiency of the kind of query that were required for this graph exploration thing that we had going on. And so we wrote a couple of articles on the Neo4j blog in 2018. And Michael Hunger said, hey, why don't you guys develop a Neo4j graph app? So we said, okay, let's go for it. At the time, there was the WrapUp gallery, and said, okay, let's do that. And we went this way. It was quite a long way, switching everything around. But eventually, we released the WrapUp for Neo4j Desktop in 2021. It was followed by an enterprise-ready Neo4j server plugin in last year. And this year, we plan to release a new RDF version, but it would be
we come back around.
We come back around, but we take what we learned about not having a model, and we decided to kind of ignore the missing parts of the model we can reconstruct in the RDF data. We can reconstruct now. We know how to do that. We can take what's there and ignore what's troubling us. So we will not have to cleanse the data. We have a fault-tolerant RDF in-memory store for the data, because most of the triple stores are not as efficient as Neo4j when it comes to transversals. Some kind of queries are very good, but the kind of stuff we do need for Semspect is there's only RDF Fox, the in-memory triple store with a very efficient Sparkle engine that actually can compete with Neo4j. So this is why we went for a new in-memory thing. But this is
Makes sense.
up and coming, and
Yeah.
we have a plan to write an exporter for the Neo4j data so that we can put this in the in-memory RDF store. So it will be a complete loop. You could put your data with Neo semantics into your Neo4j, do what you want there, apply your graph data science, whatever, export it to Neo4j to put it back in Semspect in memory. So this should be kind of fun experiments going on there.
Sounds good. And I guess, I mean, we can talk a little bit about this later, but in the world of knowledge graphs, in the world of you know, the topic that everybody talks about these days is you have to combine a couple of sources of information, a couple of your data, and it's in different spaces somehow, and it's in different formats, and some of these, especially when it comes to standardization and you know, ontologies and taxonomies, these are, as far as I know, almost all of them RDF based. And then you get this information from outside, basically the standardization part, and you combine it with your own data that you could potentially have as a property graph, and then you combine the two.
Yeah, well, nowadays there's a lot of data also in JSON LD or these kind of alternative formats that are also more like coming from document store. Maybe they have some kind of a graph structure, but it's interconnected. And you see things like open sanctions that was mentioned in one of the Neo4j videos. They produce. It's not. They do have a Neo4j dump, but it's not their main format. They have these JSON LD or CSVs, flat files, whatever, because you have different pipelines and you have a tool chain, and you have to have a format that matches your tool chain. And certainly, when you want to do graph data science, putting the things in Neo4j is a good move. If you don't need that, maybe you should go somewhere else. Yeah, but both of us are very aware of this thing because we've been involved we are involved in the Healthicore project and the COVID graph, so we know what are the things going on here.
Yeah, for sure. I mean, that's one of these projects that is very interesting to me to participate in, and very eye-opening to see how many people are actually working with this data, and how many different formats there are, and how many, you know, what a big of a struggle it is to get your data in order, because you think, okay, you have your own data set, that's okay, but then you have 20 different you know, sets of data that comes from somewhere else, and somebody else maintains it somehow, and then you have to see what to do with the data, and to combine all this information into one view.
And one of the functions, one of the uses of Semspect is looking at what have you done. You have integrated data. How is it connected? What you have used maybe a graph data science. You put data back into the graph. This graph data science library is just another input for your graph if you write it back. So you want to know what happened, and you could go and write Cypher queries. And when you write a query, you don't know, and it's empty. You have no result. Are there no result, or did you make a mistake? Are you conform to the model, or maybe you took the wrong properties? And this is the kind of stuff you cannot do. And this is why in Semspect, with this data-guided exploration that we propose, it's a tool that really is suited for this analysis.
Yeah, and we will. I think we have a look soon. Because it says here no code graph exploration. Was that one of the no code is like a recent buzzword, I would say, no code, low code, this topic. But you've been around for quite a while, and I think this was always one of the points of the software.
Yeah, the thing is, Semspect, it took time for us to realize what we were actually doing. It felt kind of natural. The concepts were developed, and instead of representing all the nodes, each node and each relation, we group the nodes and bundle the relations and display the relations between groups of nodes of given labels, and what kind of how are they connected together. And at some point, I said, "But what we are doing, it's exploration, but actually we are building queries, because we build long paths where you can filter and add conditions, And so it's a no-code query builder that's using a visual representation, aggregated representation, in order to guide the construction of the query. So it's really a visual query builder, but you are not at all using syntax. It's a kind of simple visual paradigm you're using there. And the user who are not aware of the graph structure don't even realize that they are building a query.
Yeah.
Because we have groups of nodes, each group is the result of a query that can be quite complex. But it feels natural to move from one group to the other. Because, this group, we have this relation connected to this kind of objects, and I move there. And yeah, you're building a query, but you don't realize this.
Yeah. Yeah. And I think that's one of the big advantages of the graph representation in particular, I would say. I mean, in your tool and other tools around there is you in your case maybe a little bit different, because you build the queries and then you go, but sometimes you just look, and your visual representation also is always a graph, but you look at it and you see, okay, what's the relationship between there? What is there a connection? And then you go out and look at the visualization path of it, and then you see, okay, there are things that are depending. There are things that are connected. Why are they connected? Have a closer look at these.
Yeah, and the thing is, we start with the labels and the relationship between the labels in the graph, and then you can dig in and look at the instances. We have a table view where in each group or each bundle of relation we have, you can look at the details of the properties, and you can use these properties to filter the data, so you can focus your attention on the things that interesting you, that's troubling you, or just what you were looking for. So it can be it can be used for curation, but it's also investigative. I mean, curation is an investigative task when you think about it.
Yeah, and I think it's sometimes the graph is useful, and sometimes it's really, you want to see it, you want to work with it, you want to go with it, but sometimes, like I said, you wanna get a table result. You connect your queries. You have a specific question, and you want to get something back that is more in a table kind of view, and then you don't want to see a graph. You don't care about the graph in essence, but the graph is the one tool or the technology that makes it possible to get to the table, or to get the table populated.
Yeah, I mean, then at some point you want to have a dashboard. So the thing is, you want something like NeoDash, where you have the table view and you have some statistics and whatever, or a map. But you first have to get this query that you feed into the dashboard.
Yeah.
And how do you get there if you are not the data owner, and the data owner does not understand Cypher? One of the ways to get there is to use a tool that lets the data owner, guided by the data in the thing, not knowing much about the model, knowing the meaning of a label or a kind of a relation that's there, but not interested in the technicalities, get there and select the nodes and say, okay, this is what I get. I want these things in the table, and then you just export the query you've been building and put this in NeoDash. So it's an empowering tool for graph users.
Absolutely. Shall we have a look, Vincent?
Yeah, sure. I'll start presenting. Okay. Boom. Okay.
Yeah.
Here we go. So this is just the start screen I used at the Knowledge Graph conference, where we had a small demo videos in the same session as NeoDash. And it shows, it's a kind of summary of what Semspect does. So instead of representing the nodes, each node and each relationship, we group the nodes based on the labels. And you can step-by-step build an exploration tree of the relation between groups of nodes having the same label over certain relations. And so we have the list of the labels here. We started with artworks that have been filtered here. And these artworks were created by artists, and the artists belong to fields. And like you see, we have thousands of nodes represented here in an abstract way. Some of them we can see, actually. We really see here because the number of the node is small enough to get represented in the graph. And for this artwork here, we have the table that's associated to this thing. So this, we go back to the table view. Most of the data you get in a knowledge graph nowadays comes from a table.
Yeah.
And what we do here, we reconstruct the table that was used to build this, and we give you back the access to the table. And this table is connected to another table of our relation, and this is a join. So we have a table here, we have another table there, and this is also actually a table. You have the properties of the relationships. If they have some specific properties, then they will be displayed in the table also. We have a dossier here for the objects. So the selected object here, we have all the properties of the object. This is known from other representations here. But what we have here, so we've been building a query like these here. These are the fields to which an artist belong that created one of these 3,000 whatever artworks. So and these artworks were filtered. We have an icon here that says some filter has been applied, because we have 116,000 artworks at the beginning, so it's been filtered down. And the thing is, we already built a query that returns this set of nodes here. And we try to put some useful information in there. So we see we have numbers here, and it's the number of predecessors here of objects in the left node that's connected to this. We do not represent each edge, but each relationship. But we give some number information here to see which are the most connected, and what is the degree of the node in this relation here. So we have filter function for the columns, and well, that's about it. Maybe we can see how do we install Semspect in Neo4j Desktop.
And maybe show a little bit how when you showed it. This was an image, I think. So when you how to get there, how to do it, how to
this is exactly. So I visited some of the craft summits, and I've been collecting a couple of data sets. So now I just go to the WrapUp gallery and install the Semspect application. So I'm not sure how long it's going to take, because the network at the place where I'm now, it's yes. So of course, if you install a graph app, it has to access your graph. Now Semspect is installed, and the thing is, Semspect is not only a UI, it also has a plugin that must be installed. And we chose to go our own way to install the plugin. So you start Semspect you have to allow Semspect to execute Java, because we use Java to install the plugin. So when you start the graph app and no database is started, you have the possibility to install the Semspect plugin in whatever of your database of your project you want, or install in everything. I will just install it here.
Yeah. And there's maybe this is a good point. There's a great question from Olivia in chat.
Yeah.
About the relationship between Neo4j and Semspect. Is it essential to have Neo4j to use Semspect? So
right now this version of Semspect is a dedicated Neo4j plugin. So it's a graph app and a plugin, and you need a store. You need a store for the data. So this version analyze a Neo4j database, a pre-existing Neo4j database. So you need to have that. So now we have no active database management system. So I'm going to switch my screen. I think I can close this one, and I'm going to start this graph summit here with lots of databases. in there, so we can pick and have a look. We have this art graph. We have football, movies, Northwind, offshore leagues, and whatever. Lots of stuff in there. So we can see how we can deal with that. I would like to have this as interactive as possible, and so maybe I have to switch the example to highlight something or showcase something.
So again, shout out to chat if you have any questions, anything you want to see in particular, then let us know. So Vincent can show you the right things.
Yeah, like we see here, we built our UI to install parallel to this one. So we have the projects, and here this is running. So in our UI, we should see, oh, wrong direction here. Okay, the plugin is installed and the Graph Summit is running. So I can start here. Once the plugin is installed, if your database is started, it will start Semspect directly. So it's just a workaround.
This is only you only do this once.
Yeah, you do this only once.
Okay.
So here we start. We have Semspect. We have already a database loaded. It's the football database, and then we have art graph. We have whatever here. What's interesting about the football database? It's a data set we found online. We have the labels here, and we see the labels have a structure. So this means that we recognize in the data that the events of the matches here, like goal, all the goals were also an event, and all own goal were also a goal. So we reconstruct something, a structure, label structure, that is the same thing as a class hierarchy.
And this is just, I mean, we just installed it, the plugin, we loaded it. This was done automatically.
At the beginning, we scan completely the database. We have here something to reload the database if there were changes. But this version, because when you use desktop locally, you have an enterprise version running in the background. So in the enterprise version, we can detect the data changes automatically, and we refresh all the structure here. So let's see what we have here. So our main thing is the events. Do you think you could do this in any other representation, any other exploration? We have 1 million events in there that are classified, and I can have a look at the events and see, okay, these are the properties of the events. And this is also something we reconstructed from the data. Nothing tells us that sort order or a match event time is something for the events. It's something we've been looking at everything. It turned out that we recognize the correlation between having a match event time and being a match event. And so we have a compact view. We don't have all the possible properties of your database. You have the one that are relevant for the match event. And using this, you could sort. Okay, here you can filter. Let's see if Alexander did something.
Oh, not me, but some.
Okay. So we have 3,000 events from some Alexander. And so now, looking at these events, how are they connected? They are connected to entities over an event team or opponent team. So I suppose this is the team that actually initiated the event. This is the other one. And we have player 1 and player 2. So I suppose if I go to player 1 here, what do I have? Okay, I have an entity. And this entity, it's a player. So this seems right to me, and this is something I can check.
It's a match, football match, I guess. There was 11 players in each team. So
the player 1 is a player that is involved in an event, in one of these 1 million events of the database. we could have a look at these guys, but I'm going to do something that's quite powerful now. I'm going to take these events here, and like I've been filtering with Alexander here, and I have a button here. I can apply the filter. Now let's see what happens. When I apply the filter, I focus on the match events where one Alexander was involved.
Yep.
Okay, so.
Ooh, okay.
And
Filtered
who
down.
are these guys? I should find some Alexanders in these guys. Alexander here.
Yeah.
And if I don't have an Alexander, then I should have an Alexander in the other one.
Yeah.
This is what I wait. So we are not that many Alexanders. It seems that the Alexanders are more player two. Let's see if that's the case. Because I just make a supposition. I'm looking at the data. I did not write this database. I don't know what's in there.
No.
I'm just fooling around and having a look. So let's see. Do we have Alexanders in there? Alexander, Marco, whatever.
No.
Okay. And then how are the entities? Okay, these are all the match events from this guy. So the one we filtered here are only the ones for Alexander. And then what do we have? We have a game, and we have the body parts. So what are the body parts used in the match events of the thing? And here we will see something. Here we see, okay, from the 3,000, we have information from about 1,000 maybe. And some of them, 600 were using the right foot, the left foot for 300. So we have right foot much more. And this will be the head. Yeah, this is the head. And okay, now we could use this thing. Okay, what are the goals? I will restrict to the goals here.
Okay. So
now we have on the events we are only the goals.
Yeah.
And what I could do, I don't want the own goals, so I can exclude the own goals. It's not interesting. And then I could go there and say, okay, now I want something that happens. Interesting. It seems that the values here, if it was a number, we would have a number filter here. So this means this data has been input as a string, although it's not it's not a string. So let's see the events of the 19th minute. Okay, apply filters. Okay, now we have the players that were involved in goals on the 19 minutes, and
okay. Last minute hit.
Last minute on. Okay, and who used this head for that? When I have a small list, I can also select here a couple nodes, and then restrict this to the selection. So now I have one event, one head, and like we see, we still have the other body parts here. So what happened? I restricted a group here to the head, but it did not propagate on the left-hand side. What we have is a left join. We have this table joined with this table here, and it's a left join. And in this case, we have a constraint saying this must be head.
Yeah.
In order for this to restrict that, I have to make this an inner join, a full join, and we have added the possibility to restrict the left group. Now I restrict the left group. Okay, now I got a goal. It's not an own goal. It's been done with the head. And who are these guys now? I'm going to tag this node and tag this node. Does not say much. Okay, let's have set the node caption for the player.
Yeah.
Just like you do this in a Neo4j browser. Okay, and here we have a small update text.
You see, yeah. Alexander Meyer is what
yeah.
it says in the right.
Yeah. Let me refresh this. Okay. It seems like I found a bug.
Yeah, good.
Because I would have
maybe you need to
expected
go
this.
into entity.
Okay, you're right. You're right, because okay, this is something. You're very right, because I define something for player, but this is an entity, so I would have to restrict this to player.
Yeah.
Restrict group to this label, and if I update this, no, does not work. So demo, it's a demo effect.
But we see if you click on it, we did see the name.
Yeah.
Indeed
Here
right.
we see this is Alexander Meyer, and the other one is Anderson. So the Alexander scored a goal in the last minute with his head.
Yeah.
And well, we found this without knowing much about the data, about anything. You have to understand the logic. You have to understand the filtering and things like this back propagation here. But and we started with 1 million events.
1 million, yeah, exactly. Yeah, and very, very cool, very easy. And like you said, I think this is great. Obviously, you understand. You have you know your data. You know what's in there. In usually, and then you sometimes are overwhelmed with, oh my god, I know that is 1 million nodes of matches in there, but I have no way of handling them, or what do I do with that amount of data?
And the thing is, because it's data guided, I have to. We have a wrong default here, so we cannot access the. Okay. I just did a big reset here.
No worries.
But the thing is, I'm just gonna do this maybe on a simple stuff here. I will have the body part, and okay, here interesting things. We have match event info, and we have body part to the match events. And as we see, we have 3 dark gray and 45 light gray. The light grays have no successor in there. So this might be a problem with your data. How come the match event info is not linked to body part? But maybe it's not a problem, because you also have the assist method, and this will add some connected nodes. Okay, now we connected more nodes, and then we have some pitch location, and here we connected even more nodes. Okay, so we see which are the nodes that are connected over one of these relations.
Okay, yeah.
But this can be used to detect nodes that are not connected to anything when you await something.
Yeah. That you can explore and see, okay, is this a data quality issue, or is it indeed the end of the line?
Is it awaited or not? Okay, let's say now I will make 0. Let's see this. I restrict the left group, so I want only the body parts here. And now, because I selected the things that are connected to head and foot, and then this is not an assist method, and this is not a pitch location.
Yeah.
This is something where it can produce a 0. When you apply a filter on a pre-existing thing, we have a 0. But otherwise, you have no zeros. So you have no dead end in your exploration.
Yeah. Okay.
And we could have a look. I'm going to show you how quick you can spot some of the problem with the data. This is a dump of the offshore leaks that is available through the
ICIJ.
Yeah.
Part of the big reveals with the Panama Paradise and so on.
And every time a new dump is published, I see the name of Michael Hunger pop. So, okay, Michael published a new dump. So here we have the entities. These are the companies, the intermediary, the officers are the people active in these companies, people or companies, because it's a legal person, it's not a physical person, and the addresses. And what I noticed, having a look at the addresses, just having a look here. Let's pick one. So some of the columns are empty, might be okay.
Yeah.
But look. Countries, country code, country codes.
Yeah.
This is a typical merge problem that you have. You have different data sets. And there was an interesting Neo4j Live, I think it was also, with the guy generating these the schema updates, adding new allowed properties.
The schema Smith.
Schema Smith, yeah. And this is where it's okay. You need schema Smith, guys. You have to use schema Smith on your Panama Papers because you have a problem here.
Yeah.
So this is having the possibility to poke around here. And if we look at this, if we look at this node here, okay, it's the 340. If we look at this node in browser, let's oh, I don't remember the syntax for the ID.
What's the ID? I don't know if it's what's the
I copied the ID, but it was the ID of the nodes.
You can use contains or something like that, or maybe you use. Yeah.
Somebody post this in the chat. How do I match a node ID? Oh, I can use this one.
Yeah.
What's the name? It's node_ID.
Node ID. Yeah. Use this one.
So match n and then node_ID. Help me with the syntax, guys.
Yeah, and then put in the value. Yeah.
The thing is, when you are working with too many different kind of database and everything,
I think you need the n doesn't need to be in the. You need to do it.
Match n.
No, I'm sorry. It's too hot in here. That doesn't seem right.
Okay.
And yeah, you need a what's it called, a colon.
After the n.
After the n.
After the n.
Yeah, and then you need to. Is it an address? I don't know what the value is.
Yeah, was it an address? It was an address. Yeah, perfect.
Yeah. Then the node ID, and then you can do the node ID. That should work now.
No, it does not. To have to put these back quotes on.
No, not in here. Maybe you don't need the ticks for the ID itself.
You mean it's a number?
Yeah, but node ID doesn't have to. have
yes. Okay. Yeah. So, wow. I mean, this is the problem when you use nice interfaces, UIs. You don't know how to write a query anymore.
And I should have known.
But when you look at this, you have no hint that country or countries is also available for other addresses. If you look at one node, everything is fine. And this is one of the reasons we really try to build this model here. Oh, sorry, wrong direction again. We build this model, and when you look at the columns here that we have country codes, and well, I could also choose to hide some columns here. It's so now our country is country code, and we see this, and we will have some data where we have the information in the other country. This is why it's here. So this already, the list of columns gives you an idea. Did I mix something up or not? And this is the real power of this curation engine here.
Yeah.
Now, while we're at it, let's look at the data, and we are in Germany. I think it's German, the match. Yeah. Let's apply the filter here, and let's poke around. Okay, we have 2,000 addresses in here. These are the registered address of these offices. Let's have a look at these offices. Okay, number of predecessors. Okay, we have this guy. He has 4 addresses, registered addresses in there. But that's not the right one. I already played a bit around, and I was using this one, country code. I'm going to use this one because it's more interesting if we do that, I think. Apply filter.
Okay.
Ah, no. Undo country code. Country codes. This one. Oh, I know what the problem might be. Yeah, 900. Oh, okay, now we have the entities here. Okay, we have one. We have this blue media entity has 3 registered address in Germany. But we've been always looking at this relation between groups of objects. And what about if I want to know more about this guy? So I have the possibility here to explore the connections of this one node. What are all the addresses? So some of them are in Germany, but not all, obviously. I could tag all nodes here. Germany, Isle of Man. Oh, interesting. Oh, yeah. How could it be? Could it be that this one address is used by other entities? Oh, only it shares
only 1,000.
It shares only with 1,000. So you see the investigative power of this thing here, where we work on a level where you have all these entities, and you can, how are they connected? What are the intermediaries of this guy, or the officers of these entities? 8. Oh, this one. Okay, I will buy. Okay, it's the trust. Okay, this was to be awaited. It's the big one. Yeah. It's the trust, and it's officer of 10%, 15% of these entities that share the address to this thing. So I'm always amazed. Every time I poke around, I say, wow, it's incredible what you can do here. And if you do that, looking for something that might be fishy or whatever, I was just playing around, and I see something. I say, oh, 146. Why is it that much? And then I can say, okay, start exploration with Appleby. And now I'm here, and I've got only Appleby. And I can say, okay, explore correction of the nodes. Oh, they don't have that many entities. It must be because this is one of the Apple Trust Limited. It's one of the incarnations of the Appleby Trust, the one in the Isles of Man.
Yeah, but it still is an intermediary of these, and then you see.
Yeah.
I guess it gets big quickly.
Yeah. Okay, this is the address we've been. This is one thing. When you tag a node and it pops somewhere else, then the tag is maintained. So it's it's here again, the guy I've been looking for.
Yeah.
So if and the thing is, in contrast to other things, representations, you can have more than one instance of each node of the graph.
Okay. Yeah.
Because this is a meta node. It's a group of nodes, and it's related. The conditions here is that this thing is related over this query to something in the back here.
Yeah. So you can use separate filters for the same group.
And look where ID is like this. root where ID is.
Yeah,
So
Synthesi also pointed it out in chat that this is how it works. Yeah.
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 Okay. So and what we also did is when we have not many nodes, like here, okay, this is an interesting one. Some of them are connected, some are not. We highlight the predecessors. So we try to give a hint of what would be the edges if we draw them.
Yeah.
And what you can do is you can tag all connected nodes on the branch for quick access to this thing, and these are temporary tags. So
Okay.
if you click somewhere else, select something else, it's gone.
Yeah.
But if you want to keep them,
visibility,
and if you want to keep these temporary tags, you can keep them.
Oh, okay.
So you can poke around and say, oh, this one I keep, and this one I do not. And when you're done, you can just clear all the tags, and everything is gone.
It's gone. Okay.
We have some function that restrict a group to tag nodes, because you tag something. You hover the node and say, this one I want, I don't want, this one I want, you tag it. And then you say, okay, restrict group to the nodes, to tag nodes. It's a quick way of doing this kind of stuff you would do here, selecting some of the instances here. And restricting, so we have selected the 3 nodes and restrict to selection. So it's whole lots of functionalities that were developed around this investigative task. So it's not only the curation, it's also investigation. The things we've been looking at here is very flat. This is a typical Neo4j label property graph thing. If we go to React Home, so if you go to the chemical, biochemical, biomedical, medical domain, you start getting these really big ontologies. And this is something we have here. We have gene ontology terms, cellular components, whatever publication, the physical entities and the drugs and the chemical drugs and whatever. In this case, we can show exactly what happens, what we do with the properties of the nodes, and what we display, that we try to display only the things that are relevant for a group. So here it's taking a bit of time because we have 2 million database objects that are.
Yep,
they have a top label, so it's all objects.
Okay.
So if we look at it, it's connected to other database objects of all these relations. So it's kind of it's not very practical because we connected always only to database objects. So here we have the name and the schema class. But if I say, let's say I go to a drug here, and I restrict this group to a drug, I could do this here from the context menu, restrict to label. The details were closed. There's a reason for that. It's because for the drugs, we have specific information for the drug that we can then display here. The drugs were already in the previous table, but we did not want to add every single property of the database to the table. It would have made no sense.
Yep.
So this is where, in this way, these tables are really intelligent in the way they choose to display the thing, and we use the model we extracted from the data for that.
I see. We have a couple of questions.
Yeah, sure.
So one comes from Jason, and he showed the deployment via Neo4j Desktop, and he was wondering if the Semspect could be an answer for meta-cloud dashboards for multi-cloud clients that use Neo4j or have Neo4j deployed on the cloud in either GCP, AWS, or Azure, and
okay, this is a discussion we have going on. That's ongoing with Neo4j. The thing is, we have a plugin, like I said. If we take a look, I'm going to show you the behind the scenes a bit here. If we open the plugin folder, this would be the manual installation of the thing. We have the Neo4j plugin here. And also, I also added previously a Neo4j instance here. And we store some information in a Semspect data. You can save your exploration, the kind of stuff we will find in there. And we have to install this because this does the database scanning, reconstructing the model and everything. And we cannot do that in the cloud. This is the way you would install this on a Neo4j server on-premise, just like you do for Bloom. This plugin contains the UI, and it serves the UI over the Neo4j server, just like Bloom. It's really identical. This was a tip from also Michael Hunger. They said, well, just look how Bloom does that and do the same. But the thing is, we need this plugin. If we were to reconstruct, to reconstruct this model here over the network from the database over the cloud, we would have to pool the whole database.
That's not practical.
To do this. So we know there is some work going on at Neo4j about the kind of stuff we've been doing here, analyzing the data, trying to get some model information, because it can be useful also for I suppose a kind of optimization or whatever for other tooling. And so if we find a way to add this to the APOC core, then we would be able to do this over Cypher, because we shoot Cypher query. It's all we do. In our RDF version, we had to build some complex stuff, but here in this case, Neo4j is fast enough. The queries, when we take this affiliation here and we do this thing here is the answer of queries. What we see in there here, this thing, including it's the result of a query, and what we see in there is the result of another query. So this would work over the cloud, in the cloud, if we have some information in the backend that's readily accessible in order to reconstruct the information needed. So right now we have the Neo4j plugin, the Neo4j Graph app for desktop. There's a free version that's has some limitations, but it's already quite useful. And we have the enterprise-ready Neo4j server plugin with different users, possibility to pre-compute things for the user and everything, using the role concept from Neo4j. It's really enterprise-ready. But for the cloud, it's in the clouds. The answer is still up there.
Okay. And the other question is on from Axel. Struggles a little bit with the installation. They're using it with the when he installed the desktop edition. With the example project, the pre-installed, it came pre-installed, and it's been a while since I installed Neo4j Desktop, so I must admit, I don't know what the pre-installed demo example project is, but can he get some kind of error when he tries to launch it? What do you know if that is something? Or should they try create a new project, start a new database there, and try
and put the Semspect in there and have a problem? It would have to please get in touch with me. We'll figure this out, because we want this kind of feedback. Someone has a problem in the configuration. We cannot test all the configurations, so we'll have a look at it. There's one thing I wanted to show in this database, because it has this top level object. There's one database info and then this stuff. What you can do here is deactivate the label. And what this does, it's now, if I start with affiliation, maybe let me make this smaller. Now, the connected labels are no longer database objects. So I said, do not show this in the exploration menu. So this makes much more sense here, because I navigate directly to the persons here. And I see that are affiliation that are not used by anyone. Maybe it's coming from a publication. Yes, it is. So all affiliations are used in some way. I could have tested this way also. Just yeah, all relationships, the instance edits, and so some publications have affiliation that are not. And I really have to have everyone in there. So this allows you to tune at which level you want to add, you want to work. If I reactivate this database object here and I put this in there, okay, we go for the big query again, the millions and millions of like when we see we have about 15 million relationships maybe in there. And right now, in order to build this exploration menu to know where can I go from here, we scan the whole database again. And this is really okay here. It doesn't make really much sense. But I could go here to the authors, and I suppose the authors will be persons.
Probably.
Okay, instance edit. It's a database object. It's an instant edit, or no, this is the author of something. So it's a publication or an edit on the database, because they have the person that are in there. So these are the persons here. Let's see, 120, 141. Restrict this to the persons. Come on, guy. Exclude. Oh, wrong button.
Yeah. What?
Okay, that's why. Okay, so now I can tell it's all person, because exclude the persons, and I don't have anything that's not a person that's not of the database object.
Good. And a question from V2 Belleville: does it mean all nodes have database object label for Semspect to extract the hierarchy of labels with this as a root?
Except this DB info stuff here, and this might be so. Okay, it just checks them the name and the version of the database, but all others are this database object.
Yeah. Okay. Cool. I'll post a link to Semspect and to Vincent in chat again. I think we are already a little bit over time. Anything you wanted to show before we go, Vincent? Anything final?
I don't know. I just wanted to say for the server version, we have free academic licenses and free open data licenses. So people producing open data or people working on academic projects wanting to use the server version of Neo4j, please get in touch with us. We'll be glad to assist you.
And the best way to get in touch with you is via
email.
And that's on the Semspect website, basically. I think.
Or info@semspect.de.
Okay.
Yeah, you can just get in touch there.
Yeah.
Or in LinkedIn or whatever.
Okay. Where everybody likes to be.
Yeah.
Cool. Thank you very much, Vincent. This brings us to the end of this demo with Semspect. I think it's very cool, very interesting. Graph exploration, graph visualization, a little bit also a tool, and then finding a way around the graph and finding insights, and exploring your data sets and your data.
Now we have a nice mosaic.
Exploring your data that you have a little bit more. I think this is great, and you know. Especially great that everybody can try it out via the Neo4j Desktop instance. That helps a lot to see if there's something you wanna know more of and you wanna use maybe potentially. For the next content-wise, stream-wise, we will take a short break next week. So no Neo4j Live happening next week, but afterwards, the week after, we will be back with 2 sessions, 3 actually, if you count in the Aura stream on the 31st of July with Michael, which is a recap, so rebroadcast. But on the 1st of August, Jesus and I will go into the going meta world of ontologies, semantic web, and so forth, potentially talking about the new book he's written and it's just released. And on Thursday, we talk about graph algorithms, so open source software analysis with graph algorithms. And my guest will be Dave Atel. So I'm looking forward to that. In the meantime, I'm hoping you have a good time and have a good summer when you are in the Northern Hemisphere and are sweating, hopefully not too much. And yeah, if you are in Berlin and are going to We Are Developers, I will be there next week. So if you're going to this event, then come by our booth and say hi. Otherwise, yeah, wish you a great rest of your day. Thank you very much, Vincent, for presenting today, for the demo.
And thanks to Thorsten for answering some of the questions in the chat. Very, very helpful.
Yeah. All right. Yeah, it was a pleasure. It was good fun. Thank you all for watching. See you soon on another stream, hopefully. And yeah, with that, I wish you all a good rest of your weeks. Take care.
Enjoy your vacation.
Exactly. Bye-bye.
Bye.